In this third video, of this introductory week, we're going to now look at the code. We're going to look at the syntax, the logic of how the code, and we're starting with some very, very simple examples that you might find so straightforward that you might wonder what you're really learning here. So we're going to look at Haskell, as I've said. Now, you'll get greater benefit from this video and from this point onwards if you install the Haskell compiler and environment according to the instructions that Matthew has given out. It gives you two options. You can create files using text editor of some kind and save it as a .hs file, and then you can load that up into your terminal window. So that's one approach, and I have a terminal window here, and you will notice it's got the GHC, which is the Glasgow Haskell compiler, already installed on this Mac, and it has this prompt called Prelude, which is just its prompt. So sorry about that interruption. Yeah, so you can have, bear with me a second, I'm writing down and you're not seeing what I'm doing. You can have files which you will do later on, not necessarily in this very introductory video. What we will do is we will start with the compiler, but I will shift very, very quickly for sake of aid to us and what we're doing to a Haskell environment that I've installed on a Mac. Now, this was paid for, and I deliberately bought this because in creating videos for you, it makes life a lot simpler. I wouldn't recommend paying for anything yourselves because, as Matthew will make it absolutely clear, a terminal window and you can create your files in any kind of Notepad++ or Atom. So let's just make that clear. Where am I? Bear with me a second. There I am. Right. So you can remember, you don't have to pay for anything here. You can get Atom. You can use VS Code. You can use Notepad++ to build your HS files, your Haskell files, and to execute them, you use simply a terminal window here. Now, the only issue you will have is locating your files in your file system. And after preparing and going through the material just to make sure that it all fitted together, you have to find out what Haskell is GHC is treating as your home directory. Now, if you have a Mac, your home directory is your user directory. And so it's easy to navigate using :change directory and go to different subfolders and move around to get to the right in order to load up files. Now, this will come back to you later, and the reason I mention that is that it does fit together extremely simply, but initially you might find it so much more awkward than working with, say, IntelliJ or VS Code to code. What you'll find is that you are using an editor, but you don't execute the code in an editor. You're having to go to your terminal window to do that. In this video here, we will stick to, as I said, just the terminal. So, and also to emphasize, instead of always using the terminal, I'm going to use this environment here where I can treat this little column, this second column down here is equivalent to a terminal. So if I just take a simple example that Matthew has in his notes, it executes it over here and it lets us see what's going on, right? So this is my terminal window, which is equivalent to that. So if I go to here and I type in there, you'll see it does the same thing. Do you notice? 2 times 3 plus 1 is 7. I will switch between the two so you remember that you are using a terminal window and not a paid piece of software. And the paid piece of software is to help me link in files and execute files quickly without getting lost with file paths and stuff like this. But I suspect at some point I'll have to demonstrate that to you. So with that all said, let's get to our starting point and start with a very, very simple example. In fact, probably the simplest example is this little diagram here. Here is a good way of seeing what a function is. You pass in your parameters, or another way, another term which you should be familiar with and don't struggle with, hopefully, is arguments. You pass in your arguments and you have your result. So if you pass in two values, let's say 2 and 7, then, and you've got a simple plus, you're adding them, then the result is clearly 9. Nice and straightforward. Let's just throw something into the GHCI terminal window just to demonstrate that. So we just do 2 plus 7. Well, if I can, 2 plus 7, and clearly it gives you 9. And if I just show you that in my environment, because this will help us see, you'll notice over here there's an arrow structure, and it will be very, very important later on to understand what's going on with this peculiar arrow structure and what we're up to. But essentially, that's a very, very simple exercise. Okay, so now let's look at some definitions. And here, let's get the environment. Here it's very, very important that I just write this out. Okay, and I'm going to write this out, and this is a syntax thing, so you have to pay attention to how it looks. The name of my function, let's call it square. I put here, that's the first word, and I use a pair of colons, and then I define the type of parameter that's going in, the type. What do I mean by type? Well, in this case, it's an int. And then I use this arrow, which is a dash plus that chevron, and then I type in the result type. So that there is the parameter that's going in, that's coming out. That's the first step. That defines, if you like, the types involved here. Then directly underneath, I write the actual function logic. Now, this will be possibly the one way that you may find this slightly obscure. It seems to flip over familiar mathematical sequences and the logic. Let me just remind you of what you might have encountered. If you see in standard imperative language a line which says this, n equals n times n, the typical way we read this is we start with this, we process that, and we write the result into this. Now that's for imperative coding. So straight away we have to shift our thinking, because we use a very similar looking notation, but it means something different. So the way to understand this is that this is the parameter and it's actually going in. So that's the parameter going in, and this is the result that's going to come out. So there's your parameter there. So just like that, that was your parameter, and that is your result. So integer going in here and an integer coming out. Okay, so I will get you to go back through Matthew's notes, and what I'd like to do is actually use it. So the easiest way to use it without and speedily is to write into my environment here. Now this is the equivalent of writing into a .hs file. I've called it notes.hs, and it helps me with syntax checking in this instance, but you don't need that because it is relatively, I'm going to type in int. There's that. So there's my parameter and there's my result. Now I've deliberately made the fonts really big, so hopefully they're visible. Then I need to define the actual function. So there's my parameter passing into, and there's my result. Whoops, there's my result. Now, Okay, I just had to pause there a second because my environment was just playing up a bit. As again, you don't have, you could write this into a text file. So um, let me just show this in operation. So there I have, as I said before, that defines parameter result, that defines parameter result. Let's just run it very, very quickly. And to run it, I call the name of the function and I pass it the parameter. So let's just pass it 4. And you'll notice it squared it and put 16. So if I pass it 5, 25. Now you can do all of this in the terminal, but I'm illustrating how these things fit together at this stage. So here I've got these lines in a file. Over here I've executed them. So let's get the relationship clear. And that's what this video is intended to show you. This is how you define your function, a simple function, one parameter, one result. That's how you use it. And there we go, that's its result. What I'd like to actually do before I go on to another example, because some of you will struggle with this initial step, is just show you how to run it in the console and not just in the very neat little environment I have. So there is my test.hs, which is the definition of the square. It's tiny. Let's see if I can just increase the font size so you can see what I'm doing. Bear with me a second. Where's the font? Okay, well, you can't, but those two lines are these two lines here. And so what I've done is open them up into there's the separate file, test.hs. The file is located. Now this is, and I want to illustrate this so you can hopefully iron out any kind of technical issue you have. I have a Haskell folder where I'm keeping all the material for the lecture videos I'm doing for you. And that Haskell folder, if I just show you, is sitting within my, bear with me a second, my documents folder, which is inside my home. So as I said before, it always defaults, the terminal always defaults to Nadim Anjem Bakshov, which is my home directory. So I need to get it to go inside the documents and then go to Haskell to find this file. So I'm just going to show you that very, very quickly, mainly because I spent ages doing it. So I'm in my home, so I'm going to navigate to the documents folder if I can type it correctly. Bear with me a second. Right, no error. It's changed directory. We are now looking at the documents. Now I'm going to navigate to the Haskell folder. And now I should be able to, if I've done this correctly, load the test file. Bear with me a second. Yeah, I mean, here's a typical syntactical error. When you're using these commands, you'll notice there's always a colon at the beginning when you're using change directory and load command. So I make this error, so let's just, a lot I suspect you will. There we go. Now, hopefully you can see that. What it's done is I've loaded that test file, it builds it, and now I'm inside my test file. So long story short, this is how you can load a file into your compiler. So this environment made everything nice and convenient. So I want to just run that. So if I go back to my terminal window, I should be able to type the name of the function and an input argument, and there's my result, and so on. So I would pay attention to this, and if you have time, make sure you are comfortable with the way that these things work, because working in Haskell can be a little bit of unfamiliarity in terms of working with terminal windows and so on. So let's come away from that. So to be absolutely clear, that's my file, that's my terminal window, and that's the result of the terminal window. Just for the sake of the video, it's much faster and more convenient. Okay, so let's have a look at another example. And this time we're going to have two parameters. There's the name, and that's the first parameter. Then I'm going to spell out a second parameter, and you notice that it is just the dash with the chevron sign, and that last one is going to be my result. Now, that's only part of the definition. I need to actually say what the function does. So it's twice sum and parameter 1, parameter 2. I use the equal sign to say they're going to go into this function, which is 2 times, and I'm going to add together x and y, and I'm going to multiply. So that is parameter 1 corresponding to that. That's parameter 2 corresponding to that. This is the result corresponding to that. Let's run it over here. So we call the name of the function. I can spell it. And we give it 2 parameters. Notice I'm not using brackets. So if I just give it 3 space 4, hit enter, 14. Let's just double check that. 3 plus 4 is 7 times 2 is 14. Put 13 in there. It evaluates to 34. Okay, so that's another very, very simple example, but this one had 2 parameters, and that's how we listed them here. So we have other ways of doing it. Now, Matthew in his lecture notes does talk about the GHCI terminal window, and a shortcut, a cheat shortcut would be to say do this. If you are, what I'm going to do is just get a new terminal window up. Bear with me a second. And then I'm going to reload my GHC compiler. GHCI, execute that. Now the instructions should hopefully all be clear. If I create a function, let's just call it TS, and the function defines a parameter going into a parameter times 2. Now implicitly it's done all the definitional work for me, so I can just type in TS4 and TS, let's test it out, TS5, and you can see it working. So this looks like it's just the second part of the definition of a function. Implicitly, the environment is happy to do it, and so I can test out this part and this part directly in the terminal window. Okay, so these examples have just used an integer whole number. They're relatively straightforward because from a parameter you can see the result. What we're going to end on is just looking at a couple of other types. You have a Boolean type, a true false, which is called bool. Obviously you have the int, you have a float, which is a floating point decimal, and you have a character which deals with strings. Now bool is probably the area where some of you may get stuck with the logic and how the logic. So let's pause for a second and have a look at a simple example of a Boolean function and test it out. Let's say that I create a function called x, or I define it as receiving one bool, a second Boolean value, and the result is a Boolean value. Okay, so then what is it actually going to do? So let's write that out. So the actual function is going to take 2 parameters corresponding to the x and the y here, and that's going to be put into this statement to evaluate. X, the double down slash represents, can you remember what it represents? It's a logical one. A double and %, what does that represent? Can you remember that? The word not, and I'm running out of space. I'll type this x and y. Now what that line represents are parameter 1, parameter 2. This is the result. X or y, and not x and y will evaluate a true or false. It implements what's called an XOR logic. And if you are trying to get your head around it, it would not hurt you at all to work out how using this notation to define an and, define a standard or, define all the various different logical gates. There's a little bit of practice for you, but let's type that in and test that out into our environment so we can see this in operation. So I'm receiving a bool. Second parameter is a bool, and the result is a bool. I'm going to, bear with me a second, hit enter. I'm going to now, parameter 1 is x, parameter y is a second argument, and this is the logical statement. So I need a bracket. So let's just write this out. So it's x or y, and I'm going to clearly run out of space here, so I'll have to expand my window a bit, and not x and y. Close that. Okay, so let's test that out. And how do we test that out? What will it receive for us to use it? So we go x or true, and let's say true, and it evaluates to false. If it's true false, it evaluates to false. No, it evaluates to true. And can you see it doing over here? Let's make it false false. What does that evaluate to? Evaluates to false. So here it shows you the same logic of how a function is both defined and how you execute it. There are some very, very neat qualities here, and you might start spotting them, that once you get your head around how to define a function, to execute them is relatively straightforward. Remember, I could do this part. Let's grab that line here a second. Let's go to a terminal window. Let's pop it into the terminal window. So we've got the function name. We're leaving the types out of the statement. So let's just run it. XOR, put in true, false, hit enter, comes back with true. Sorry about that interruption. It's my phone just went. Okay, so if I do true, and it evaluates as false, just as we've seen up here. So we see how we can use Boolean values. We have integers and floats. I'm going to skip those, and I'm going to skip if statements for your subsequent week. When we come to if statements and conditions, and we have some really interesting syntactical and conceptual ideas that are important for you to see.